The chemical shortcut that rewired civilization. It looked like efficiency, a faster way, a smarter route, one small chemical shortcut that promised the same result with less effort. No one imagined it would rewire civilization itself. At the moment it appeared, the shortcut seemed almost too simple to question. It offered the same outcomes that older methods delivered, but without the delays, labor, or complexity that once defined them. To engineers and planners, it felt like progress distilled into a single reaction. To society at large, it felt invisible, just another improvement quietly folded into daily life. The promise was not transformation, but convenience. To understand why this shortcut matters today, we need to look at how societies respond to ease. When chemistry offers a faster path, resistance fades quickly. Efficiency feels rational, even responsible. Systems reorganize to accommodate what works best. Habits form around reliability. Dependence grows gradually, long before anyone pauses to examine what has been displaced. By the time questions arise, the shortcut already feels essential. At first, the shortcut solved a real problem. Processes that once demanded time, skill, labor, or scarce resources could now be achieved cheaply and repeatedly. The reaction delivered consistency where uncertainty once ruled. Variability disappeared. Output stabilized. Civilization accelerated, not through grand redesign, but through countless small decisions to choose the faster option. Industries adapted almost overnight. Infrastructure reshaped itself around the new chemistry, optimizing supply chains and production schedules to match its pace. What was once optional became standard. Older methods were sidelined, not because they failed, but because they could not compete with speed. The shortcut did more than improve outcomes. It reset expectations of availability, cost, and immediacy. But chemistry always charges interest. Shortcuts bypass stabilizing steps for a reason. Reactions that move faster often skip natural checks that once absorbed error and variability. What was saved in effort was borrowed from the future. The system worked beautifully, until it was asked to handle more than it was designed for. This is where the story truly begins. With a reaction so convenient it became invisible, a chemical decision that quietly rewired how civilization functioned, long before anyone stopped to ask what it was replacing. Once embedded, the shortcut no longer felt like a choice. It felt like reality. As the shortcut spread, chemistry began shaping behavior as much as it shaped matter. Once a faster path existed, slower methods felt irresponsible. Efficiency stopped being an option and became an expectation. Systems were redesigned to eliminate pauses, delays, and redundancies that once provided resilience. Chemistry did not just speed things up, it changed how time itself was valued. Natural cycles were compressed. Processes that once unfolded gradually were forced into continuous motion. Where pauses once allowed correction, acceleration demanded constant throughput. The shortcut encouraged a mindset where slowing down felt like failure. Chemistry enforces logic without judgment, responding to pressure exactly as physical laws dictate. At first, the gains were undeniable. Output increased dramatically. Costs dropped. Access expanded to scales previously unimaginable. The shortcut delivered stability and predictability on a level that reinforced trust. Civilization leaned into it without hesitation, building plans and promises around its reliability. But shortcuts collapsed safeguards. Processes that once filtered errors were bypassed. Buffer stages disappeared. Chemistry still worked, but the system lost its ability to absorb shock. When disruptions occurred, there was no slack left to catch them. The same efficiency that created success magnified vulnerability. This is where early conflict emerged. The shortcut created dependency. Removing it meant collapse. Maintaining it meant pushing chemistry harder to meet demand. Each cycle reinforced reliance, tightening the system around a single point of failure. Choice narrowed even as output grew. Scientists began noticing subtle warning signs. Secondary reactions increased as byproducts accumulated. Waste streams grew more complex, interacting in ways not fully anticipated. Recovery systems struggled to keep pace with continuous output. The shortcut was efficient, but unforgiving. It tolerated little deviation. Chemistry had delivered convenience at scale. And with that convenience came a quiet fragility that civilization would only recognize once it was already deeply committed. The shortcut did not fail. It performed exactly as designed, revealing weaknesses not in chemistry, but in how thoroughly society depended on it. The conflict intensified when the system encountered stress it was never designed to handle. Supply interruptions rippled outward. Environmental limits asserted themselves. Human error, once absorbed by slower systems, now cascaded rapidly. The shortcut left no room for recovery, because recovery had been engineered out. Chemistry responded exactly as it always does. It amplified pressure. Reactions optimized for speed behaved unpredictably under strain. Minor disruptions multiplied, spreading through interconnected systems with startling speed. What once felt controlled now felt precarious. This buildup carried emotional weight because the solution was no longer technical. The chemistry had already been optimized. There was nothing left to refine without introducing new risks. The problem was structural. Civilization had traded resilience for efficiency, and chemistry enforced that trade without mercy. Attempts to reinforce the shortcut introduced additional complexity. More inputs were required. Controls tightened. Energy demands increased. Each fix kept the system running, but shifted fragility elsewhere. Stability became temporary and localized, never systemic. This realization marked the emotional peak. A single chemical shortcut had shaped everything from production to behavior. Reversing it was no longer realistic. Too much depended on it. Civilization had been rewired not by intention, but by accumulation. The reaction itself remained neutral. It followed physical law without preference or consequence. The conflict existed entirely in how completely society reorganized around it. Chemistry had not failed. It had succeeded too well. And success at this scale carried consequences that could no longer be ignored. The climax arrived with a simple realization. The shortcut was never meant to carry the weight of civilization. What began as an improvement had become a foundation. Chemistry designed to save effort was now responsible for sustaining entire systems. When foundations are built for speed instead of stability, every crack spreads faster. This understanding reframed the problem. The shortcut itself was not wrong. It was incomplete. Chemistry had optimized one variable while quietly sacrificing others. Efficiency replaced resilience. Convenience replaced adaptability. The resolution lies in redesign, not rejection. Reintroducing buffers, slowing critical steps, allowing chemistry the space to correct itself instead of forcing constant acceleration, measuring progress by durability, not speed alone. Civilization is now learning what chemistry has always known. Shortcuts change more than outcomes. They change structure. Once embedded, they shape behavior long after their benefits feel ordinary. This story is not about going backward. It is about remembering that chemistry works best when aligned with natural limits, when reactions are allowed to breathe, when speed is balanced with stability. So what do you think? Are we repeating the same mistake again?